The compound changes in the value of a quantity can be an increase or a decrease. For example, when compound interest is paid on an amount of money, the amount appreciates. This is a compound increase. If the value of a car depreciates over a time, this is a compound decrease. Compound interest is where interest is paid on the interest from the previous time frame, often a year but not always, as well as on the original amount. This is different from simple interest, where interest is only paid on the original amount. Step 1. Identify previous and latest quantities. Step 2. Keep multiplying the previous value by the decimal equivalent. Pay attention to the number of compounding periods to get the latest value. So in question 1, a savings account pays compound interest at the rate of 3.5% per annum. That means per year. And Mark puts €5,000 into the account. We're asked, how much money will be in the account after 8 years? And we need to give our answer to the nearest euro. So the calculation is as follows. 5,000 multiplied by 1 plus 3.5 over 100, all raised to the power 8. And this gives 6,584.05. So that's 6,584 euros to the nearest euro. In question 2, we're told that a particular investment sadly loses 60% of its value each year. The question continues, if the investment is worth $3,200 3 years later, what was its initial value? So if we use capital I to represent the previous value, then we can write I multiplied by 1 minus 60 over 100, all raised to the power 3, must equal 3,200. That's the latest value. And simplifying and rearranging, this means that I equals 3,200 over 0.4 to the power 3. And this gives $50,000. Now we're told that in question 3, Timothy bought a house for £180,000 in 1990, and that in 2014 it was valued at £1,500,000. The question continues, what annual rate of compound interest is this equivalent to? Give your answer to 3 significant figures. Now we can start with the following. 180,000 multiplied by 1 plus r over 100, all raised to the power 24, equals 1,500,000. That's because this is 24 years later, and r is going to represent the equivalent annual rate of compound interest. So 1 plus r over 100, all raised to the power 24, equals 1,500,000 over 180,000, and this simplifies to 25 over 3. Now if we raise each side of the equation to the power of 1 over 24 and then subtract 1, then r over 100 equals 25 thirds raised to the power of 1/24, subtract 1. Therefore, r over 100 equals 0.09236. And so multiplying by 100 and giving our answer to 3 significant figures, r equals 9.24%.